Good morning to one and all. I am A. Sri Kirtana Reddy. I am from Annamacharya Institute of Technology and Sciences, Rajampet. Today I am here to give a demonstration or a brief idea to our project. Let me move on to the project. Let me share the screen, please. Our project title is a novel Bayesian fusion model for IR and visible images with histogram analysis. Before going to see the main aim and introduction to our topic, let me have an idea. What is Bayesian fusion model and what is histogram analysis? Now let's see what is Bayesian. A probabilistic method for fusing information from different sensors. It is purely based on Bayes' theorem. Is nothing but a Bayesian. The word fusion refers to is a process of combining two or more different entities into a new whole. Here we are considering two distinct entities that are nothing but infrared and visible images that both combined to form our output that is nothing but fused image. Now we are detecting our output with the help of histogram analysis. Histogram is nothing but the differentiation and it is a representation of pixel values with respect to the intensity ranges or nothing but it is a graphical representation that organizes a group of data points into a user specified ranges. These are the table of contents. Now let me give an introduction. Image fusion. As information enhanced image processing technique used to produce a robust or informative image is a hot issue in a computer vision today. In this task, a fused image containing both the gradient and detailed texture information of visible images as well as the thermal radiation and highlighting targets of infrared images is expected to be obtained. Our demonstration can generate fusion images containing highlighted targets and abundant detailed texture information, which may potentially improve the reliability of the target, automatic detection, and recognition of the system. The main objective of our work is, compared to previous method, our model has good performance on almost all matrices, which demonstrate the excellent fusion effect of our model. It can quickly generate high quality fusion images with rich texture details. Now let me move on to the need and importance. Basically, a fused image containing the detailed texture information is our aim. It can facilitate automatic detection and accurate positioning of the target. Now let me move on to the advantages. In existing approach, the implementation of algorithm details were omitted. In existing approach, its relative speed is less, whereas in proposed, it was high relative speed. In existing approach, it failed for 3D images, whereas in proposed method, it supports for 3D images too. Proposed system is more reliable and follows simple algorithms. Compared to previous existing methods, the model can generate better fused images with rich texture details, which can improve the reliability of the target. And these may improve to generate better fused images. Now coming to the limitations. These were less accessible to many of investigators because the analyses are usually run using software that is unfamiliar or less familiar to many of them. It requires greater statistical expertise than some other methods. Of course, the software is more expensive, probably sensitive to the prior probabilities were chosen. Existing method and proposed method. The existing method is a Bayesian approach for data and image fusion. In this, the main aim, one bit of information or one bit of data is transferred from one fusion image. It is more complex and it is more hard to implement. And the implementation of algorithm details were omitted and its relative speed is too slow. So, to overcome all above limitations, we proposed a model that is a novel Bayesian fusion for IR and visible images, where it can generate better fused images with highlighting thermal radiation targets. Its relative speed also too fast. Coming to the tools, we are using our 2017 Beam version MATLAB tool that were installed in PC. Let me give an idea on MATLAB. A MATLAB is a programming platform designed specifically for engineers and scientists to analyze and design systems and products that transform our world. The heart of MATLAB is the MATLAB language that uses a matrix-based language. The block diagram included in our project. The phases of Bayesian fusion are duplicated in the block diagram. Let me show. Here the first block represents the raw inputs, which are nothing but infrared and visible photographs, are first imported from the data sets. Then image acquisition is done. Acquisition is nothing but the action of retrieving an image from the source. After acquisition, the parameters, prior independent variables, are set. The photos are transferred. Before acquiring the genuine image, the altered image or complex conjugated in fast Fourier transform, and the undesigned particles in the photos are removed. The input images are divided into several subparts depending on their intensity values using a Fourier-based transform. The deconstructed components of the image with input attributes are then subjected to a sophisticated conjugation procedure, which returns the real and imaginary elements of the input image. The conjugate image is other term for the real image, where we get real image from this block that is nothing but a complex conjugation block. Now move on to the next block, that is iteration or loop iteration is started, and then filtering is employed to remove unwanted particles from the image. The filtering operation is carried out to terminate any disturbances introduced during picture acquisition or to round up to the nearest fraction values. After filtering, the required image is obtained. The associated mean values are then computed and the inverse fast Fourier transform is employed to build the necessary fused image, which is then obtained as a final input. After that, the picture histogram analysis is done for both IR and visible image, and our required fused output is created. Let me move on to our sample results. Now we are taking sample inputs that are nothing but IR visible image. First, we are taking the first input infrared images. Now seeing on this picture, we done an analysis, that is histogram analysis. The histogram plot is primarily used to determine the likely distribution of pixel values in relation to picture intensity levels. This figure shows the distribution of pixels is primarily in the middle of intensity ranges, which actually ranges from 50 to 180. Furthermore, it can be shown that distribution is not a smooth process, but rather when it is a rough or uneven process. Next, our input image is nothing but visible input image. Here, histogram plot of the input visible image retrieving the distribution of pixels dispersed across the complete range of intensities, which actually ranges from 50 to 250. In addition, when compared to the infrared images, it can be seen that distribution is rather smooth. Then finally, our output, that is from both IR and visible image, we got the fused output image, the output image. Now seeing on this picture, the histogram plot of the fused output image displayed the distribution of pixels across the complete plot of intensity, which really ranges from 50 to 200. Furthermore, when compared to infrared and visible images, the distribution is smoother. And finally, I conclude that image fusion is considered This work using a Bayesian model with Fourier-based transform and filtering operation used as preprocessor steps for deconstructing and enhanced processes respectively. The fusion of these two images can produce us with smooth and polished information as evidenced by our output results and histogram analysis in this work. These are the references related to our project. And thank you for giving me such a great opportunity. Thank you one and all.